Hello, everyone. Welcome to today's webinar, How to Gain Back Your Velocity When Working with Kubernetes, with Lucas, co-founder and CEO of Loft Labs. Good morning, good afternoon, good evening, wherever you are joining from the world. Just a few housekeeping items before we get started. You can put your questions in the chat window in LinkedIn, and we will get to that mostly in the end, but also we will pop some questions in the middle. Uh, and I'll be your host, Rahul. I head the growth marketing here at Loft, and I'll be in the background moderating the questions. So now over to you, Lucas.
Yeah, thank you so much for the introduction, Raul. Let's get this session started. I prepared a couple of slides. As Raul mentioned, I'm Lucas, the CEO of Loft Labs. We're working on a whole bunch of open source Kubernetes tools, including vCluster, DevSpace, and a couple of other projects that we're involved with. And velocity, developer experience, those are really important things in pretty much anyone's journey who has to deal with code day to day. So, looking at Kubernetes, everybody's like, Kubernetes is complex. Kubernetes may actually slow you down. So, how can we, kind of get back to this very, very efficient workflow that we had pre-Kubernetes? That's essentially what today's session is about. To essentially go back a few years, let's take a journey back down memory lane. Um, a few years ago, the world was a lot simpler, right? Um, every tech startup that was created like 10, 15 years ago, whether that was GitLab, GitHub, a lot of companies, essentially bet on Ruby on Rails, and they were super happy with their stack, right? Because it was super efficient, it was easy for engineers to get up and running in velocity is really key in business, and then also obviously in tech to create business value. um, Back then it was super straightforward. We essentially fired up a Rails server with two words, right? It's like super straightforward, starting this Rails server at our local machine. And then if you wanted to deploy that, we essentially just did a git push, Heroku main, I guess these days, Heroku master back then, to deploy a branch. And then essentially we ran the command Heroku open to get a URL to access things in the browser, be able to test it, right? Write some local scripts to test against our, REST API or whatever we were building. Um, Things were a lot simpler back then. And then a few years later, complexity increased in terms of, people were serving global audiences. Cloud became a thing. Distributed computing, essentially emerged for the masses. And then suddenly, monolith was not the great option anymore, right? They really sucked, right? And everybody was like, we need microservices, we need Kubernetes, right? Kubernetes started um, to emerge, and every tech startup started in that cycle. Essentially saw the issues of the monolith and why they were betting on a different technology. um, Monolithic applications have a couple of issues. They're very tightly coupled. So if you have a Ruby application and you start out as a small startup, that's great, right? Velocity is amazing. We can ship this pretty quickly. We can build new features and actually get that app out the door. But down the road, we're going to have like so many different use cases. The platform that we're building is expanding, and ultimately, this tight coupling turns into dependency hell, right? Because suddenly we have to have 10 people involved to figure out, can we ship this new feature, or will that break something else somewhere down the road in our monolith? And that's pretty problematic. So ultimately, we have a very, very centralized application with a monolith. That means we have stability concerns in terms of, if we're upgrading something, if we're changing something, um, does that affect something else, right? Let's just think about, infamous like database migrations that were underestimated and are super hard to roll back, and effectively brought down entire, um, internet services that thousands or even millions of people were using. So that's really problematic. And then you have things like upgrades become very, very complicated, and that really slows down your release cycles. And that's really not what we want. So, you know, I guess we need microservices in Kubernetes, right? So everybody was kind of like, moving on the new hype train of like segmenting monolith into different, um, microservices, shipping them in containers, using tools like Docker and Kubernetes to orchestrate our microservices in the cloud. And that solves a lot of these concerns, but it introduces new concerns because microservices and Kubernetes may really slow you down. And a lot of engineers actually are facing this right now. That's why we're talking about it in this session. Because when we're thinking about our previous, Rails application, it was really like Rails server to start it up, Heroku push to essentially instantiate it, right? Heroku open to get a URL. If we're thinking about the same workflow with containers today, if we do it step by step, it's essentially we have to build and tag images. This command alone is a lot longer than Rails server, right? And it's just building and tagging an image. It doesn't do much more, and we have to push an image to a registry, right? The part I didn't include here is like, how do I even get the credentials for that registry? Where does that registry live? What is our tagging strategy? How do images get cleaned up again, right? Whoa, there's a whole bunch of complexity on that end. Then we got to deploy. Look at this bulky command, right? Use 2 lines of code here in the slides for this because, yeah, we got to, use Helm, use Customize, plain manifests. I'm, sparing you the whole wall of YAML here, but that's essentially living under the hood here as well. And that's not very, very simple. And then if we want to now expose an application, access that application, well, the first step to doing anything, seeing the logs, opening in a browser, port forwarding, etc., is like finding the pod name, right? Because Kubernetes is distributed, so we don't really know, like there's no fixed name, right? Our application is not called API server or something like that, right? Our pod has some kind of suffix to it. So we got to find that, then copy it, then run a command like kubectl port forward. And well, guess what? If we want to make a change, right, we have to start at the top again, right? And we can't skip any of these steps because, well, we do need a new image. We need to push that new image. We need a Helm upgrade again to upgrade this. And then we need to find the pod name again because the pod name will have changed because Kubernetes will not recycle the name of this pod. And then we start our pod forwarding again to this new pod that has been created in Kubernetes. So that's not very, very fast and efficient, right? This is not our Heroku push, and it's accessible for us. Um, so when people see workflows like this, in the past couple of years, there has been a new trend emerging, which is actually an old trend, and that is to reply to complexity with we need to pass, right? Because pass, that was Heroku, right? That was my first example earlier in these slides. Um, but it's a repeating pattern, and we're going to go into why this pattern will not be the ultimate solution in a second. But let's just take a look at the history of pass because it's very, very interesting. While creating this presentation, I was actually surprised that there's a very, very static cycle of passes being created after certain complexities have been introduced, and then passes always, it seems like the solution, right? Um, so in 2007, we had Heroku, we had Google's App Engine emerge. So that was like the OG pass essentially being created. Heroku is still the gold standard for successful pass today. Um, but then again, like a couple of years later, there was another wave of pass with AWS jumping on the hype train, Cloud Foundry being created for the new, cloud world to essentially easily provision clouds and large enterprises. Um, and then there was the whole like Docker container ecosystem happening, Tutum, and then Dot Cloud, which ultimately kind of turned into Docker. Those passes, came a couple of years later, and today, we're seeing passes emerge based on Kubernetes to kind of solve the complexities, not of containers, not of cloud, but of Kubernetes now. So we have things like Google Cloud Run, which try to be that pass layer on top, and there's a whole bunch of others. The Rancher founders just started company to build a PaaS on Kubernetes. There's a whole stream of companies, open source developers focused on building this new PaaS. So why is this pattern repeating every 4 years or so? Why is everybody thinking, well, we need a PaaS for this, right? We need to layer this. It's very, very, very interesting. And I think what we always see after a few years into the PaaS journey is people start hating that pass, right? And it's interesting that repeats because I think passes have a couple of benefits, and being opinionated actually is a huge benefit. Um, but by being opinionated, a pass also really limits a user's choices, and that may be problematic because if Heroku doesn't support that database that you need, right? So they have a MySQL available, right? But you need something else. You need a time series database. Well, then you're quickly hitting the limits of what your pass can do for you. Pass is also a lot of magic, which obviously solves a lot of problems initially because the magic does things under the hood, so you don't have to invent them, think about them, configure them, right? Um, and that's great. But having magic also really obstructs debugging. It really hinders the user to dive deeper because we're essentially just seeing that pass layer, right? We can't really dig a lot deeper with Heroku. We don't know what's happening under the hood, and that really impacts the capabilities of an engineer to um, debug things and dive deeper into what may be going wrong, right? How to optimize certain things. Those things are very, very limited. And then pass ultimately means abstractions. It's layers of abstractions. Each pass adds a layer essentially. Um, and that creates kind of a lock-in, right? It may just be, in the case of Cloud Foundry, it may be open source lock-in. In the case of Heroku, it may be a lock-in into a SaaS platform. But ultimately, it's a lock-in into the way of doing things. And then once you actually get to the point where, that magic and the fact that the past is so opinionated and limiting you in certain ways, that lock-in becomes problematic. Even if it's an open source lock-in, it is often problematic to have that lock-in because you're doing things a certain way, and you're really bound by the ways of your past. So how can we solve this nevertheless, right? Kubernetes is complicated. Everyone from beginners to experts sees that. How can we actually get around Kubernetes being so complicated? That is still an open question, right? um, Kubernetes has endless choices in its ecosystem. And that's really, really great because, like look at the CNCF landscape, right? Sparing you that image that you see in every second talk, but there's like thousands of tools on there being created in the open source space. And that creates two things. It's very exciting because, you want to try all these tools and you have a lot of possibilities. That sounds very great, but it also leads to two things. And the first term is actually that was new to me by while creating this talk is decidophobia, right? So the fear of making a decision. So you're looking at like, should I use Solo or should I use Istio or Linkerd, right? What am I using for a certain what am I using for my service mesh, or what am I using for my API gateway, right? You're looking at all of these tools and you're like, um, which one are we picking, right? We want to bet on the winning horse, but which one is it, right? So you're kind of holding off because you're not going all into one because you're not sure yet which one is gonna get the broad community adoption and get the 20,000 stars on GitHub, right? Um, so you hold off on making that decision, and that's actually really problematic for a business because we can just stand still. We got to move forward. We got to ship new features. We got to satisfy customer requests. So the cytophobia is really a blocker in tech when you have so many choices and you don't make um, just a decision. In a lot of cases, it's actually pretty ironic that it doesn't matter which decision you make. Later on, you can always refactor things, and you can always switch things over to a different tech stack. I know so many companies that bet on Docker Swarm and Mesosphere in the early days, and then Kubernetes won, and well, they just had to make a change towards Kubernetes. Spotify gave an interesting talk about this at KubeCon, I think in what was it, 3 years ago, about them building their own orchestrator internally and releasing it the same day as Kubernetes was publicly announced. And that was super unfortunate, right? But they still went with their technology for a few years because it just worked for them. And at some point, they realized, okay, Kubernetes, because it's open source, because it has so much backing in the community, is actually outpacing what we can deliver internally. And then I made the switch to Kubernetes. And sure, that was probably painful, and there was probably a lot of work that went into switching from their Helios platform, which was their internal tool, to to Kubernetes. But ultimately, that was possible, right? And that's a very fundamental change they made from the container orchestrator platform to another one. But those things are possible. So ultimately, just making a call is better than not making a call, right? You got to decide with something. But there's also another effect of so many choices in Kubernetes, and that's FOMO, right? You're like, oh, there's this new tool, I got to check it out, right? Oh, there's this new option, right? We got to jump on this hype train, right? You have this fear of missing out on things when these new hypes emerge, and that's another thing that really is very, very common in Kubernetes space. Kubernetes is also perceived as very complicated because it's very explicit. And I see that as a benefit because it is, Kubernetes is not a lot of magic, so it's always clear what's happening, right? And there's always some kind of YAML option to tweak whatever you need to tweak for your specific scenario or use case. Um, but it leads to YAML help very, very clearly, right? Everybody knows this. That explicitness, right? We got to state everything. So that actually, leads to, complicated YAML manifests and, really overloads people a little bit. Um, and then, Kubernetes is ultimately very composable, right? There's not just like, it's not like a Rails monolith that says like, we'll deal with all of this for you. It essentially lets you pick and choose for everything, right? So you pick your storage, you pick your networking, you pick your service mesh, you pick your API gateway, right? Like all of these different things. You're not really bound by the framework or the specific path. You have a lot of flexibility, but that also leads to complexity because you have to decide how are these things working together. So when you're making these choices and when you're explicitly defining what should be running, you kind of need to wire things up in the right way to actually, seamlessly work together. And there are very few tools that help you, integrate things very, very smoothly in the Kubernetes world. So there's some legwork to do on that end for sure. Um, when we're thinking about, so how can we alleviate some of the pains here? How can we actually make Kubernetes a lot more approachable for engineers so that they don't face all of this, right? A lot of companies have started doing platform engineering, right? A lot of teams within companies are concerned with things like developer velocity, developer experience now, and they're building tooling for their internal teams to essentially have this like golden path that teams can use to get a great experience and build features very, very quickly. And and if you ask me, the biggest thing for these teams is that they should be looking at how can we build transparent abstraction rather than passes, right? Because you can build some kind of internal pass, or you can build on top of things like Cloud Run, but ultimately you're locking your users in again into something. If you're asking me, I would actually argue transparent abstractions is what a lot of companies are looking for. Um, and in my opinion, that means we're building something that is client only. So we're not building this, you know, bulky paths that we're sending requests to, and it somehow handles stuff for us magically under the hood. We're building something client only that is based on kubectl. We're building something CLI first, so engineers can use it in their terminal from their VS Code, right, or whatever IDE they may prefer. And we need to make sure that whatever we're building on that end is customizable, is extensible, because ultimately every company, every team, every project within a company is different. And it just, whatever we're doing, it needs to have that flexibility for folks to essentially build out their specific use case. And I think one big benefit we have in the Kubernetes world is we have the Kubernetes API, and that's actually the huge, huge benefit of Kubernetes. It standardizes the way on how to define things, right? With this explicit YAML language, or JSON actually under the hood being kind of pushed back and forth between kubectl and in the in the Kubernetes API server. And as long as we stick to that, as long as we're building something for our engineers that streamlines their workflow, but essentially ties back to a kubectl command, right? If I'm able to run these commands via kubectl instead of the CLI, that's a transparent abstraction. It means that I can use the tool to streamline certain things because it just combines certain commands, it executes them in a certain order, it finds the right way to execute them. But I can literally tell the tool, and it's even better if the tool can explain it to me. Please tell me, how does this command, what's the equivalent in kubectl or Helm or any other higher level tool based on Kubernetes? So I can essentially say, well, if you run this command, it under the hood runs these 5 commands for you. And that's really smart because it makes things understandable for engineers, especially when they want to debug things, when they want to dive deeper. So we're not hitting that pass limitation of like, oh, now we're stuck, right? Now we're stuck with our pass and we can't get past that. That's essentially what we're preventing by betting on the Kubernetes API. And luckily, and that's towards the end of the slides and more towards the practical part of this webinar, is there are actually tools out there. If you're asking me what is the best tool, I would say that's probably the wrong question to ask, right? Because it really depends on what you're looking for and the requirements you have for a specific project, team, engineer culture, right? There's so many factors to consider, so I can't give you a single answer to this, but I can give you a couple of suggestions here in tools to look into. CNCF always is a great starting point. There are 2 projects in the CNCF sandbox right now that you may want to consider. Telepresence, they've been in the sandbox for years. They have the approach of, hey, you deploy your services, how will you deploy them? We don't really cover that piece, right? We don't do image building, we don't do Helm install, right? Like none of these things are covered. Um, but we're essentially deploying things. But after it's deployed, we're helping you now connect your localhost dev environment to your remote deployed services so that you can run one service locally, and then the other microservices run inside the Kubernetes cluster, and they do some network magic to essentially say, hey, your local service is now connecting with these remote services. It's a very, very interesting tool. Was a very early tool in the Kubernetes development world. And then DevSpace, that's actually one of our tools. We've been building DevSpace for a couple of years now, and now put it in sandbox in the CNCF. So I'm super excited to kind of list it here next to an amazing tool like Telepresence. DevSpace takes a little bit of different stance as Telepresence. It has a broader scope. So it also covers things like, how do we deploy this application? If you want to, you can obviously tell DevSpace not to take care of that. But if you wanted to cover things like efficient image building, and then tagging, pushing optionally as well, including Helm install, customizations. However, we're standing up our 20 microservices. DevSpace can cover that, even dependencies across Git repositories. And then it introduces, unlike Telepresence, it doesn't let you run a service locally on your laptop. Instead, it runs everything inside a Kubernetes cluster. But the services that you have an IDE window open for on your local machine that you're working with, they get hot reloaded. That means without having to image build, you actually can update the container in real time. And that introduces a whole lot of velocity because these commands I showed you earlier, image building, pushing, tagging, etc., that takes a lot of time. With DevSpace, we're just entirely skipping that. We're deploying the prod version of everything, and then we're hot swapping things inside these containers. We're switching out binaries, we're switching out source code, we're switching out static assets via a sync mechanism, and then essentially hot reload these containers really, really immediately upon any changes you make on your local file system. And then we do things like port forwarding in the background. We let you hook up your IDE via remote extension, for example, VS Code's remote extension is pretty awesome. So you can connect to these dev environments if you want to. You can use remote debuggers with them. DevSpace supports all of these different things to really let you build that perfect developer experience for your team. And then there's a broader ecosystem of tools that I would encourage you to look into as well: Scaffold, Tilt, Octado, Garden. Those are just a couple of tools outside of the CNCF projects that I would strongly urge you to have a look at. There's like 50 other tools here as well. Unfortunately, I don't have a ton of space on the slide, so I can't list all of them. But definitely have a look at, I think the section is called App Definition and Microservice Building, I think, on the CNCF landscape, where you can see different other tools in this space. And yeah, that's essentially the end of my slides over here. Raul, do you want me to dive right into a demo, or pull in some questions beforehand?
Uh, we can get into the demo, and I will pull up
Okay.
some questions in the meantime.
All right. Perfect. Then let me close this. So I'm gonna show you how DevSpace works, just very briefly. Walk you through the getting started, and show a couple of examples of what you can do with it. Um, and we're going just through our quick start guide. Of course, I already downloaded DevSpace. I have it on my local machine. You can install it via npm yarn brew. Just download the binaries. It's a client only binary tool, so you can literally curl this on your local machine, put it in your path, and it's up and running. It's client only, CLI only. The only thing you need is a valid, kube config, kube context, so you actually have a Kubernetes cluster to develop against, and that can be in EKS, in AWS in the cloud, right? It can be your private cloud, can be your home lab, it can be Docker desktop, right? It can be Minikube, whatever Kubernetes cluster you have available. And we also create that portability for teams, because we know teams use different Kubernetes clusters. They may be Kubernetes experts that have a different setup than beginners who just download Docker desktop, for example. In this case, I just downloaded Docker desktop to demonstrate this. You need a project to work with. So in this case, I'm just going to go with this Node.js example, but there's also one for Golang, Ruby, etc. Right? There's so many different languages that DevSpace work with, and obviously you can bring your own project to develop it with DevSpace. So if I open up VS Code here, first thing for me is to retrieve this quick start project. Let's have a quick look into this. It's a very, very simple project. We have an index.js file here, which essentially just spits out some HTML. That's all it does on a specific route, on a specific port, right? And we have some HTML code, and we're starting our server here on this port. That's all we're doing. Very, very simple, one file JavaScript application. Obviously, we have a package JSON. This is an Express, web server, but again, this could be anything else, right? And then we have NodeMon to kind of do like even hot reloading in the container to make it even faster. But essentially, this has nothing to do with DevSpace, right? This is just some JavaScript project. And what we need to do now is we need to initialize this project for DevSpace. The way to do this is with the command DevSpace init, but you can also find examples in our Git repositories. But this is kind of a guided setup process, right? So it first looks at the programming language. It saw a couple of JavaScript files, so it says like, hey, is this JavaScript project or a different language? We just confirmed this is JavaScript. It's going to ask us how we want to deploy this project, and now we're getting started actually recommends to use Helm. But we can also go with plain manifest, of customize, right? I'm just going to go with Helm right now because it's one of the most popular deployment tools. And then it detected, oh, this is actually a quick start guide. So I don't need to ask you 20 more questions. I'm going to condense it down to one or two if you, answer yes here. So we'll say yes in this case to save some time. And we have the question here. Is this just for deploying the project, or do we actually want to hot reload and develop it? In this case, we're saying, yes, we have the source code in this repo. We want to develop it. The Docker file is here. It already detected that, so it's suggesting that. We can also tell it use a different Docker file, use an alternative build tool like Bazel, for example. In this case, we'll just go with the recommended Docker file here. It's showing us, hey, do you want to use the GitHub image registry, another registry? Do you want to skip registry entirely without image pushing? because as I said, we have that hot reloading mechanism anyway. It also detected I'm signed in with Docker Hub, so it's suggesting that right away. I'm just going to select this over here. It's going to check my credentials real quick. And then it creates this file here called devspace YAML. And the devspace YAML essentially codifies how this project or any project would be developed, right? So we see this is a version file, so we can have different versions of devspace YAML and different Git repositories. Devspace is going to internally migrate these things. We also see down here that our IDE detected that this is a devspace YAML file because we have the JSON schema published. Which is very nice because you get autocomplete here for this YAML immediately. You don't really have to install an extension or whatever. It works out of the box to autocomplete things. We see pipelines here, which are going to tell us what happens when you start a development mode, what happens if you just want to deploy things. It specifies where our images should go if we wanted to do image building, how we deploy, for example, with Helm in this case, and then how the development should be done with this project. To develop a project like this, the first thing we need is Kubernetes cluster, right? I said I'm using Docker Desktop right now and their Kubernetes cluster. We can actually check that here. Yeah, we see this is quite old, this Docker Desktop cluster. If we want to have a fresh cluster that we just use as a throwaway cluster, right? We can also use one of our other open source projects called vCluster, which creates a virtual cluster inside a Kubernetes cluster. Great thing about this is you essentially have the capability, although you have this one Kubernetes cluster with Docker Desktop that it provides, you can now create several virtual Kubernetes clusters for different projects, trying out different things, right? And they don't affect each other. Anyone who's ever broken a Minikube cluster or a Docker Desktop cluster knows that it takes like 10 minutes to reset this, and it's like very annoying because everything's gone, right? Because you messed something up, right? Some finalizer was set and you don't know why this namespace is not terminating, right? Like all of these issues can happen in Kubernetes. So instead, we can just run a virtual cluster with our vCluster CLI. I'm going to call that VC1. And that's essentially deploying this virtual cluster for me. And then it's connecting me to this virtual cluster with a kube contact that points into this virtual cluster. And then inside that virtual cluster, we can now use devspace to develop. Again, we can also skip the virtual cluster part entirely and just work directly inside the Docker Desktop cluster. But with our new virtual cluster, you can see here, our namespaces are all like 16 seconds ago because we just spun up this virtual cluster. And we have a fresh cluster now, right? No matter what happened in Docker Desktop beforehand, we have a fresh, empty Kubernetes cluster. And we can run devspace dev in this cluster. Devspace dev is the core command. Oh, it's actually asking us, do you want to use the default namespace? We recommend not to do that because you can't delete it in Kubernetes, so it's much easier. Although you can create and delete the virtual cluster very quickly, you may still want to keep that virtual cluster around. So I'm just going to answer no here and use devspace, use namespace, and then we call it just dev, right? Which creates a new namespace called dev. And now we can run devspace dev going to this dev namespace instead of the default namespace. And you can already see where the user experience, devspace has a lot of these best practices in there. Like it's seeing, using default namespace, do you actually want to use it? It may not be a best practice, but it also leaves you the option to still do that, right? And it's all just kubectl commands under the hood, right? So this took maybe 10 seconds or so, and we're inside a container now. Instead of being on our local machine, these files are still on our local machine, right? This devspace YAML is on a local machine. But our terminal down here is inside the remote container. Let me see if I can actually show the processes in here. We see there's some syncing going on, there's some tunneling going on, some SSH forwarding going on. That's what devspace does in the background. But we're also seeing that the PID1 is sleep. So although our container would contain the production version of the service, right, it wouldn't fire up that production version because we want to develop the service. What it does instead is start the sleep mode. So we can now start the service ourselves. So we can run npm start here to actually fire up the application. And what that does, it automatically opens the browser as well, right? We see, hey, it's time to code, right? Just our HTML that was created. And we can see here now it's time to code. And if I go into my IDE and into this JavaScript file, I can now make changes here, right? We see, for example app listening on, and then listening right now on, right? And I can say the line that we saw earlier, now it's time to code with dev space, right? And as soon as I save this file, you see down here, the application reloaded. And we can see our changes, right? Listening right now is what we changed. We can go to the browser, we can reload here, and we can see time the code with dev space, right? All these things that we just changed in that file take effect immediately. And that's because this container was not running PID1 npm start, it was running sleep. And we manually started npm. That means we can also, go out of here, add our package JSON, and then run commands like npm install, right? Add new dependencies, etc. So we're moving essentially our entire, execution engine into the container. Our runtime is the container now instead of our local machine, but we can still edit and work on our local, VS Code, which really boosts productivity. Because let's say you have 20 microservices and you want to debug communication between 3 of them, right? You may not even be able to run 20 microservices locally, right? And you may have difficulties spinning up each one individually. It's really hard to know how to do all of this for each one of them. Here, it's as easy as running one DevSpace dev. DevSpace will stand up not just the current project, but also all of its dependencies, so all the other Git repositories you may need. And it does that in seconds. And then if I want to develop 2 services, I open 2 VS Code windows and run DevSpace dev there. And then DevSpace does a hot reloading mechanism for these 2 particular microservices. And now I can debug them, right? See the communication, see the logs in real time, have control here, add dependencies if I need to, and really get this like hot reloading workflow for all of my containers that I want to work with. That's essentially how DevSpace works. But again, there's a whole bunch of other things you can discover in DevSpace, including commands like, there's shortcut commands. Like if I want to, for example, run kubectl exec, right? I need to run kubectl get pods first, copy the pod name, etc. DevSpace has a shortcut for that. It essentially has the command devspace enter, which is our exec, right? And it immediately drops it into container. Or if there are multiple pods in that namespace, it would essentially ask you, please select one of the containers. And it has a really nice selector where I can use a keyboard up and down keys to select which container I want to use. And then again, as soon as I'm done working, I can exit out of there. And this may be running in an EKS cluster or so. So I can now turn my virtual cluster off by running vcluster pause and pausing the virtual cluster. Or I can run vcluster delete to entirely wipe the virtual cluster and then use a blank new one next time. And again, I can have 5 sleeping ones in the background, and I can work with 3 virtual clusters in parallel. So that combination of DevSpace and vcluster is also very, very powerful to boost developer velocity. All right, that's pretty much the end of this demo. I think we're already running a little bit over time, Raul. But do we still have time for questions or no?
Yes, we can pull up this question. Where's the difference between a pass? Yeah, right here.
Got it. There's a difference between a pass with a lot of config options and your transparent abstraction for you. Wouldn't transparently adding a list of different components to your Kubernetes lead to some more config overload for the engineers? Yeah, that's an interesting question. So I think the big difference, I think, between what I call transparent abstraction and a pass is that I can go deeper, right? So if, for example, DevSpace would not support port forwarding, right? This here still deploys to Kubernetes. This here still creates a pod, right? So if I'm actually using my vCluster again, and again, I can connect to that, I think with vCluster connect VC1 or vCluster create VC1 again, um, we can see that there's a pod in a Kubernetes cluster. I can run kubectl get pod, and I can run kubectl kube forward, port forward, sorry. Um, that means I can do these things um, even if the pass doesn't support it, right? Versus the classical pass doesn't allow you to do that. The classical pass does not allow you to work with, what is with the VM under the pass, right? You can't do that usually. But what you can do with a transparent abstraction is you can access the underlying Kubernetes cluster because it's based on the Kubernetes API. It's client only. There's no server as an intermediary translating something, right? It's essentially just in the CLI. So dev space dev command can be translated probably to like 30 different kubectl commands. And if I need to run 2 or 3 more, I can do that because dev space and kubectl are using the same kube context. They're talking to the same Kubernetes API. That's what I mean with transparent abstraction. It's essentially built on that common API rather than building some proprietary or even open source REST API or GraphQL API on top of it. It doesn't really need to do that. That's why I would also argue it's so important to be client only for building successful tooling in the Kubernetes space. And again, a lot of the tools that you see in the space are actually following that pattern. It's very, very interesting that a lot of different engineering teams apparently see that this should be the way forward.
All right. I know we are just over time a little bit, but Lucas, can you talk a little bit about the CI/CD use case and maybe any kind of integrations and how they work with DevSpace? Just a quick thing.
Yeah, yeah. I think a lot of teams are essentially starting their journey either in CI or in dev when they start using DevSpace. So they pick either one of these two use cases, but because they're so close to each other and DevSpace essentially works for both of them, they start using the other use case as well, right? So I may be picking DevSpace for the development use case. And then 3 months down the line, I see like, okay, I got like 50 happy developers. There's like 100 other developers who are still on the path to adopting it. But we also have some struggle in CI, right? And we kind of want to standardize things, CI and development. We want to essentially have this, we really, what we do with DevSpace is give developers a production-like environment without having them, by codifying everything into this DevSpace YAML file, we essentially have a declarative definition of what a great workflow should look like for developing this, right? So we can also specify a great workflow for how to run integration tests with this, right? And how to spin up an environment that you can run end-to-end tests against, right? And it makes a ton of sense to start with one of these use cases instead of starting with like 2 or 3 all at once. But if you are, if the I is what is your biggest issue right now, start with that use case. If dev is your biggest issue, start with that one. And then you'll see that there is so much value in expanding dev space to the other use cases as well, because you're maintaining the same kind of principles and the same dev space YAML. There's a lot of reusability possible. Um, that dev space is really used by a lot of teams for multiple of these use cases. And CI is super interesting. You essentially run something like vcluster create to spin up a virtual cluster. Again, like if you have like 50 different branches in your Git repository and so many different microservices, right? Do you really want to create a different Kubernetes cluster for each one of these? You probably can't, because it takes like 30 minutes to create a virtual a Kubernetes cluster inside EKS, for example. You can obviously use namespaces, but not every application can be contained in a namespace. Someone can bring an entire cluster down if they're running in a namespace. So why not create a virtual cluster, right? You run vcluster create inside your CI pipeline, and then you run things like devspace deploy, and then you run a command like devspace run end-to-end tests, right? And then you have a 3-line, essentially CI pipeline that runs end-to-end tests, and you add 2 more lines and you get preview environments for each pull request, right? And it becomes very, very easy to set these things up for great experience in CI as well. I definitely think that's super, super interesting. And with the hot reloading in development, you're also preventing that people abuse the CI as a, a lot of people can't run 20 microservices locally anymore. They need data from some kind of cloud bucket, right? So what they end up doing today is essentially, pushing to Git all the time because they want to see, do things still run there? Does it still work there? And instead, what you can do is you can have preview environments created, end-to-end environments created, etc. And then they can connect to these environments via DevSpace and debug them right in there instead of having to do a new Git push again, right? Because every time you run your pipeline, it's going to create a new image. It's going to take forever, right? It's much better to say, hey, this integration test failed. We're not immediately cleaning this environment up. We may just pause that virtual cluster to save resources, but then the developer sees that that integration test has failed. I can use devspace dev, right? I run a command to retrieve the kube context to this environment, run a command to run devspace dev, and I can see what's not working here and debug it right there in that failed CI environment. And it's such a better experience than, pushing over and over and like, oh, it works on my machine, but it doesn't work in CI. Why not? Right? And, it's so much easier to just hook yourself into that CI environment that it makes a ton of sense using DevSpace for both of these use cases ultimately.
That's super helpful. Thank you, Lucas. All right, I think we are at time, so we can wrap it up. So thank you everyone for joining us. Please follow us on LinkedIn, and we have an exciting webinar next month coming up. It's with one of our customers, and you will get to see like how they are actually using to scale their workflows in engineering. So you can sign up for that. You can see this QR code, and we will also post it on LinkedIn. We will send you the recording afterwards. Once again, thank you for joining us today. Thank you, Lucas, for insightful presentation.
Yeah, thanks everyone.